Hi guys, welcome back. In this video, we'll see how to find the time complexity and space complexity of binary search. Okay, using big word notation. So, what is binary search? Binary search is half interval search, and the array has to be sorted. That is very must. Okay, to search the element 5 from 8 elements, this is going to be my task. So, I have 8 elements, and I'm going to find the element 5. Okay, so if two elements for the midpoint, then consider the first term. So here the midpoint is 7 and 8. Okay, now I'm going to take only first element as the midpoint. So 7 is my midpoint. Okay, my target is 5. So my target is being compared with the midpoint, that is less. So remove the element array of element after the midterm. So after including that midpoint, just remove all the elements. So that is, I'm going to remove all the elements. So I'm going to consider only 3 elements now. Okay, so now my new midpoint is the middle term 3. I'm going to compare my target with the midterm. So what is it saying? My target is less than the mid. I'm sorry, the target is greater than the mid, is it not? Target is greater than the mid. So what happens? All the elements are removed, all the elements smaller than that midterm are removed. So my target now, my this is going to be my only element, and it is compared with the midterm, and it is compared with the target, and the output is true. Okay, now this is the concept of binary search, and with the 3 iterations, with it, you can easily find out the target element. Okay, so this is a beauty of binary search, and let us see what is the best case, worst case, and average case of time complexity. So my binary search has the best case as 0 1. I'm sorry, big O of 1. By big O of 1, the possibility of first element itself is being the target element. So that is my best case. Average case and worst case are being big O of log n. Okay, and the space complexity is big O of 1. You know the reason? That is, same memory is required as the input. Okay, no extra memory is required, so the space complexity is big O of 1. So now let us see the reason why the average and best case are big O of log n. So here comes the reason: the target element not the first element. Then in how many search will I find the target element? So that is nothing but the log big O of log n searches. We found the target element 5 in 3 searches, right? Then how can be this formulated? That is, we can using the log, we can just formulate the above logic of finding the element, target element, in which, in how many searches. So let us see this. Big O of log of n equal to k. I'm going to just assign a variable k to this log. Okay, now my n is 8 here, right? And this is going to be my search. K is nothing but number of searches, n is nothing but number of elements. So according to this log rule, log 2 of n equal to k, it can be written as 2 power y equal to x. So 2 power k equal to 8, and how many times? So this is of base 2, right? 8 is also converted into base 2, 2 power 3, 2 power k. So k equal to 3. So we require 3 searches for 8 elements in binary search. Wow, how amazing, right? So this is the average and worst case. Okay, formulation, which is nothing but big O of log n. Now I hope you understand. If you like, just give a thumbs up and comment below your valuable suggestions. Thanks for watching. Bye. To learn more engineering concepts easily, just don't forget to subscribe, like, and comment.